Good morning. Welcome back to Dr. Logic Awkwardly Does Logic. We've had our digression through systems 1, 2, and 3, and now we're going to start talking about systems 4 and 5. You'll recall that our motivation for this started from looking at converses of 4 theorems of T, which if we add them to T, give us modal reduction principles. We noted that 2 of them, or 2 pairs of them, are equivalent to each other, so that reduces our consideration down from 4 formulas to 2. And then we noted that one of them implies the other one. So we basically got 2 possibilities. We can either add necessary P implies necessary P, or we can add possibly P implies necessary possibly P. And if we add that latter one, we get a stronger system because it implies the first one. I'm just going to bring up the whiteboard so that we actually can see this written down rather than just hearing it. But we are building on system T. So that is K plus the axiom necessary P implies necessary P implies P. And then our 2 options are we can add to T necessary P implies necessary P. This is system S4, or we can add to T possibly P implies necessary possibly P, and this is system S5. Now, S5 is strictly stronger than S4. So we've got our inclusion relation. S4 contains more theorems than T does because we have added this new axiom, and S5 contains strictly more theorems than S4 does. Now, even though S5 doesn't have this axiom as one of its explicit axioms, we've shown that from this, you can prove that. And that is why everything that you can prove in S4, you can also prove in S5. Now, in a little bit, we will talk about an alternative axiomatization, which makes it clear how it is an alternative axiomatization of S5, which makes it clear how it is an extension of S4, because we will get it by adding the S4 axiom plus something else. In the meantime, let me just give you a bit of terminology. This axiom here, because it is the characteristic axiom of S4, is often called the 4 axiom, because it's the characteristic axiom of this system. Now, naming axioms and identifying formulas is not a precise science. So the other axiom, the one that we add to get S5, isn't called 5. It doesn't have a name. It's just possibly P implies necessary possibly P. But the 4 axiom is one that you'll read about in the literature. We'll be referring to it by that name in what comes forward. So just worth saying that now. So this just gives you the definitions of S4 and S5 and a little bit about their motivations. Now, behind all of this motivation was what are interesting modal reduction principles that allow us to go from many iterated modalities into smaller iterated modalities that are going to be easier to understand, more intuitive, and give us a bit more insight into what is going on in these systems. This is what we'll start talking about in the next video. We will look at what the iterated modalities are in S4, what are our modal reduction principles, and what can we say about how many distinct modalities that we have in that system. And we get some really lovely results, with the further result that S4 and stronger systems end up being really easy to prove things in terms of theorems. Proofs all of a sudden get so much shorter when you have modal reduction principles. So that's what we'll talk about next time. Join me then, and until then, take care.